So next we will see like which assignment we have to do in practical for heap tree. So the problem statement given by university is like read the marks obtained by students of second year in an online examination of particular subject. Find out maximum and minimum marks obtained in that subject. The condition here is we have to use heap data structure and we have to analyze the algorithm. So analysis part, it means how many comparisons are needed, but that we have already focused on that number of comparisons required are n log n. Okay, so the complexity tends to be go of n log n for heap tree. And all the basic things which are related to heap tree, they are already covered in the earlier session. So we know what is heap tree. Now in this case also we will build a max heap where the value of root is greater than its children. Okay, where the value of root is greater than its children. So this is how we have to perform the program for heap tree, or we can call it like if I build the heap tree, then I have to find out which are the minimum marks obtained by the students and which are the maximum marks obtained by the students. So how can we do that? Once the tree is hippified, we can perform delete operation. And after performing deletion operation, deleted values will be stored in one array, right? So we know the values are always stored in descending order when they are deleted from the max heap. So those deleted values only it will be in sorted order. So the one which is present at index 0 will be the maximum one, and the one which is present at the last index in the array will be minimum. Okay. So this is my program for performing heap sort, and I have deciphered this program so that you will understand it clear. So let us get into the program. This program is very simple, and even the lines of code is like smaller than as compared to other programs, maybe like AVL tree or something. So the main aim here is we will be given with some marks. So as per the problem statement, you have to read the marks obtained by student in particular subject. Now just for demonstration purpose here, we have taken one pre-initialized array and the elements of array are 12, 11, 13, 5, 6 and 7. So now if I draw the plain tree, it will be like, see, these are the elements which are given in our array 12, 11, 13, 5, 6 and 7. So if I draw the tree, it would be like 12 at index 0, 11, 13 at next level, index number 1 and 2. Then the last three elements, 5, 6 and 7, they will go at index number 3, 4, 5, that is at level number 2. Okay, so if I try to draw a complete binary tree for this, this will be like this. Now I have to perform heapification so that it will satisfy the property of heap tree. So for this tree, let us get into how can we perform heap sort on that and how the tree will be heapified. So let us get into the main program. So this statement, what it is doing, it is just reading the, not reading, it has pre-initialized some numbers which will be stored in the sorted array. 12, 11, 13, 5, 6 and 7. Generally what we do is generally we ask the user that how many students are there, or we ask how many numbers you want to store in the heap tree, right? But here we have taken some pre-initialized numbers. So that's obviously fine, not a problem. Now, if the directly pre-initialized array is given, you should find out how many elements are there in the array. Now, one way to deal with this is find out size of array. So we know how many numbers are stored here. We know that 3 plus 3, 6 numbers are stored. If I consider that integer takes 2 bytes, so 12 divided by 2, it will give me what? The total numbers which are stored in my array, right? So the better practice could be you ask the user how many student marks you want to store in a heap tree, that is n, and then by using cin statement, just read the marks of student. This is just for demonstration purpose. So I have taken some pre-initialized number over here. So int n is equal to, I want to find out how many numbers are written over here in the array. You can physically count and you can write, but the better way to deal with this could be size of array. That is, suppose if we consider integer requires 2 bytes, then 6 2s are 12 divided by size of ARR of 0. Okay, so here int n equal to what? 12 by 2, it will give you 6. So it means that the total, how many values are pre-initialized in the array? N equal to 6. Now, once you read this input part, next you have to call the function, that is heap sort. So now I have written a function called heap sort and I pass two parameters to this function. First is input array in which my numbers or what you call it as marks are stored, and another is n. Now what is n? Just we have find out how many numbers are there in the array. That is nothing but n, and now it is passed to the heap sort function. Now let us see what this heap sort function is doing. So this is a main function which is performing heap sort. So as already discussed, two parameters are passed to this heap sort function. One is input array and other is total number stored in that input array. Now what we have to do is we have to build the heap from the given input numbers. Okay, so building the heap means what? We have to perform heapification operation, because heap tree cannot be built without repairing, without performing heapification. So now while building a heap tree, I have to perform heapification operation. Now, if you blindly write these numbers in a form of complete binary tree, see 12, 11, 13, 5, 6, 7, these are the values entered by the user. So if I store it in a tree, it will look like this, right? Now, can you please identify the numbers or the nodes on which heapification has to be performed? So we can clearly see here, I need to heapify which nodes? Number one, root node. Okay, number two, this internal node indexed 1, and number 3, this node which is indexed as 2. Leaf node need not to be heapified. We know in heap tree always internal nodes and root must be heapified. Now the main question arises here, how you will decide the nodes which are to be heapified. For example, here I need to heapify 12, 11 and 13. Why? Because 12 is root and 11 and 13 they are internal nodes. The leaf nodes I know I need not to heapify. You know? So in order to perform this heapification, I must write one for loop which will allow me to find out the internal nodes and root node on which heapification has to be performed. So just see how I have written this loop. I is equal to n divided by 2 minus 1. So we know n is what? Total number stored in the array. So how many numbers are stored in the array? There are 6 numbers. So 6 divided by 2, what is that? 3. And 3 minus 1 gives me 2. So initially value of I will be equal to 2. Initially value of I equal to 2. So what does it mean? We start from the rightmost node which is indexed at 2 and we perform heapification starting from this rightmost node which is stored at index number 2. So I is equal to 2 and then what is condition here? I must be greater than equal to 0, I minus minus. What it simply means, if I start to perform heapification from this node that is indexed at 2, I will perform heapification on node 1, indexed 1. I will perform heapification on a node indexed at 0. So how this loop will go? This for loop will be repeated for 3 times. 1 when I is equal to 2, that is for this node 13. Then for I is equal to 1, that is for the node 11. Okay. And at the end, the heapify function will be called for this node, which is indexed at 0. Now what happens? I minus minus. So 0 minus minus will become what? Minus 1. And then minus 1 greater than equal to 0. This condition will become false. And then this for loop will exit. Okay, so now we have to see, it's okay that we have seen how many iterations this for loop will take. So this for loop will take how many iterations? 3 iterations. That too for what? That too for 1 for root, and for remaining internal nodes, heapifications will be called on. Okay, now as heapification is part of each of this iteration, let us get into like what this heapification function is internally doing. So now let me show you the code for heapification. So this is my heapify function, and what this heapify function is taking as input. This is taking your input array as input. Okay, so this is integer array as input. Then int n, that is nothing but size of your heap tree, number of nodes which you have stored in a heap tree. And at the end, I have index I. Now you can see what is I here. Every time I called heapify, I pass this index I. As I already told, the heapification is started from this rightmost index node, internal node, that is 2. So initially, heapify will be called on input array, then n, and the I value will be 2. In the next iteration, I value will be 1. In the last iteration, I value will be 0, and so on. So when I call this heapify function for first time, value of I passed over here is 2. Okay, what is value of I passed here? 2. That is, we are heapifying which node in our example? We are heapifying this node 13, which is indexed at position 2. Now what we have to do for this? In this heapification function, we know that I want to heapify this node. So already we know what is heapification. Heapification is, as this is a type of max heap, we have to compare value of this one with value of its left child and value of its right child. Now here we don't have any right child, only left child we have. Okay. So what we do is we check the value of left child. So value of left child is 7 here, and 13 is already greater than 7. So there is no need to swap them, right? So 13 is already larger. Okay. So here no heapification is needed. But now I will tell you another case where we can see the node 12, which is indexed at level 0, at index 0. Okay. Now, if I look at child nodes of 12, they are 11 and 13. So I should find out whether the left node is having greater value than the root, or the right node is having greater value than root, right? So I have to find out here which child possesses greater value than the root. So we have already a formula which is telling us that if parent node is situated at index I, then its left child is always at 2 into I plus 1, and the right child is always at 2 into I plus 2. So same case we have used here. So what we did, whatever index value was passed, that is considered as I. So what I assume, initially I assume that the I value which is passed is nothing but the largest. Okay, the I value, we know what is I value passed here, 2. So the element which is present at the index I is my largest number. That is what I am assuming initially. Okay, but after finding out left and right child value, if I get greater value than this I, then I will swap them. Okay, so initially value of this largest is assigned to I. That is, whatever index I pass, I consider value of that internal node is largest before I inspect the value of left and right child. Now we know how we can get left child. If the parent is at index I, then left child would be at index 2 into I plus 1. So int L is for the left child. Okay, int L is for left child. Int L equal to 2 into I plus 1, and the right child int R equal to 2 into I plus 2. So this formulas already we have discussed. So we know that what this 2 into I plus 1 gives us is, it gives us position of the left child, and 2 into I plus 2 gives us position of right child. So once I get this position, then I have to find out whether the left child is having greater value than largest, or the right child is having greater value than the largest. That is nothing but my root. So how I will check whether the left child is larger than root? So very simple if condition. If L is less than N, of course I know that. See the value of left index. Here, the parent is situated at index number 2. So what will be the left child position? 2 into I plus 1. That is 5. And what will be the right child position? 2 into I. 2 plus 2 into I plus 2, right? So 2 into I, that is 2 into 2, 4. 4 plus 2, 6, right? But I know that total number of nodes here are 0 to 5, that is 6. There is no node present at index number 6, because as indexes are started from 0, the total element in that case could be what? They will be 7. If it is going at index 6, it means that total how many nodes are there? It means that total there are 7 nodes in the tree, which is not true. So for checking this particular thing, that is whether the index of left or right child, it must be smaller than your n value. So if L is less than n and ARR of L is greater than ARR of largest. So initially what we have assumed, largest is nothing but the root value. Okay. Whatever internal node you have considered, that is nothing but largest. That is what we have considered. But after this, if we get largest value than this, then that left value or right value is assigned to largest. So how we have checked this condition? If L is less than N and ARR of left is greater than ARR of largest, then of course the left node is having largest value. So L will be copied into largest. Or else if the right child is larger than largest so far, then again we check if R is less than N so that it will not cross the total number of indexes in the heap tree. That's why R is less than N and ARR of right is greater than ARR of largest. So if this is the case, it means that the node present at the right position is greater. Okay. So what I do here is I copy the right element value in the largest. So based on whether left child is greater or right child is greater, that corresponding value will be copied into largest. Or yes, third case could be root is already greater than its left and right child. Okay. So if largest is not root, it means what? The value of I will be different and the value of largest will be different, right? So in that case, what you will do, if you get larger value than I, which you initially assumed, then you will swap this I value with the largest. Okay. So swap function, what it will do? It will simply swap ARR of I with ARR of largest. So if this is the case, 12, 11, and 13. So we know the largest value which we will get here is 13. So 13 will be swapped with 12. So this is just for example I am telling. So what this swap function, it will swap these two values. And of course, after swapping, again we need to call the function recursively to check whether the remaining subtree is hippified subtree or not. But now, which parameters you have passed? Earlier it was array n and I. After performing this swapping, now you will pass this largest as a third parameter. Okay, so here we have given call to the recursive function called hippify, wherein we have passed array, the n, that is total numbers in a tree, and then the largest value we have passed. Okay, so this is how the hippification function is working. What this function is doing, to summarize, this function simply find out which is the greater node, which node, the left node is having larger value than parent or right node is having larger value than parent. So the one which has a larger value than parent will be swapped with I value. So this is what. And after performing swapping, again we have to perform hippification operation. On what? By passing this largest value, the one which is just swapped with the root. Okay. So this is how hippification code can be written. So this hippify function, it will be first called for I equal to 2, that is for 13. Then again it will be called for I equal to 1, that is for 11. And again it will be called for I equal to 0, that is 12. So once the I value becomes smaller than 0, then this particular for loop will terminate and it will go down here for the next for loop. Now what we have to do? Now we have created the heap tree. As I already suggested, if I want to sort the numbers in descending order, I simply need to delete elements from my heap tree one by one. Okay, I simply need to delete element from my heap tree one by one. Okay, now how it will be deleted? We know that in case of heap tree, what happens? The element which is present at the root is deleted. And the element is deleted and it is swapped with whom? It is swapped with the last element in the array. So for that purpose, we have taken this for loop in a reverse way. So what we are doing here, int I equal to n minus 1. So we know the total values here are 6. So 6 minus 1 will give me 5. I equal to 5 initially, 5 greater than 0. So how this for loop will go? 5, 4, 3, 2, 1 and 0. Now what I am doing here, I am swapping ARR of 0 with ARR of 5. So what will happen because of this? ARR of 0, that is the root, will be swapped with ARR of I. I is what? The last one, right? So I is initialized to n minus 1. So it means index number 5 in our case, right? So here by using this for loop, we are swapping ARR of 0 with ARR of I. And once we make this swapping, again we are calling this heapify function. So that to heapify the reduced heap. Okay. So heapify is called on what? Again, it is called on array. Then it is called on I, wherein value of I is n minus 1. That is the last index in the array, right? Because indexes started from 0. So 0, 1, 2, 3, 4, and 5. We know that in our example, we have only 5 indices. Okay. And once we perform this swapping, again we call heapify function by passing index number 0. So what will happen because of this? We will get the sorted array. And once we get the sorted array, we have to simply print that array. Now how you will print it? You will simply use this function, a small function which is written here. Two parameters are passed. One is this array, input array itself, and another is n. N is nothing but total numbers in my array. So how you will print it? Very simple way. For I equal to 0, I less than n, and I plus plus ARR of I. Now you know that this array has stored numbers in the descending order, right? So if you want to print the maximum marks, you print the marks which are stored at index number 0. And if you want to print the minimum marks, then print the marks at the last index, that is index number 5 in the array. Okay, so likewise, the program for heap sort can be written. Now, as I suggested, instead of taking pre-initialized number, you all have to read the numbers from the user. Otherwise, the underlying logic, remaining logic will be same. So to summarize the program, what we did for this, in order to create the heap tree, what we have to do is, I have to read the marks of students from the user. Once I read the marks, I know the marks will be stored in array, like as and when they have came. The mark which are first read will go at index 0, second will go at index 1, third will go at index 2, and so on. So this is how I create a complete binary tree. Now I have to heapify this tree. So for heapification, we find out which are the internal node on which heapification operation has to be called. So how to find out those internal node? N by 2 minus 1 and I greater than equal to 0. So if I repeat this loop, then I will get the numbers on which heapification has to be performed. So the process of heapification, it simply means that you have to find out whether the left child has greater value than the parent or whether the right child has the larger value than parent. So you have to find out the largest child node and you have to swap it with the parent. Okay, after performing the swapping, again we call heapification by passing the largest value which we have just find. And once we repair the tree, once we heapify the tree, and then in order to show the sorted numbers, we just go on replacing the number which is there at index 0 with the last number in array, so that we will get finally sorted output. Analysis part, I have already told that as this is a complete binary tree, the number of comparisons required would be big of n log n. So this is how program for heap sort can be performed. Thank you.